I'll record this and post it anyway. Anyway, nice to see you guys. I wanted to go over some basic things in person. There are recordings of me posted, and there will be more for different, for the different topics. But I did want to go over the basics of the camera in person, so that if you have questions about about cameras in general, about your specific cameras, we can do that in person. And of course, I do have office hours every week at this time on Wednesdays. And if that doesn't work for somebody, email me and we can try and arrange a different time. Okay. So, any questions or issues, comments before we get started? Anybody? No? Okay. I don't know how many of you have cameras yet. Normally, you would need a film camera for this class, but since we are virtual and we'll be working at least superficially with Adobe Lightroom and possibly Photoshop, you don't have to have a film camera. So that's up to you. You can use a digital camera. And we'll convert our images into black and white and look at them and work on them in black and white. Okay. I do advise you to shoot in color, even if your camera allows you to shoot in black and white, because then you have that information in color. You can always convert it to black and white, but it gives you more options. Okay, so I want to talk about, sorry, it's hot here. I want to talk about cameras in general for a couple of minutes, and then we'll look at our specific cameras. So let me just share the screen here. Can you guys see this? It says SLR. Anybody?
Yep.
Yeah, okay, cool, thank you. So this is a film camera, and it's the type that's been used for film for 60 odd years, I guess. And it's certainly not the only type of camera out there. It wasn't at the time, and obviously it is not the only type now. But it is the most common type of camera that's used in photography, and it's called an SLR, or single lens reflex camera. And single lens sounds kind of silly because obviously it has one lens, but that is to differentiate them from cameras that do have two lenses. So anyway, single lens reflex camera. Obviously, many of us use our phones now, and those are not really anything like this. But this is the type of camera that we would be using with film. And you are welcome, in fact, kind of encouraged, but you don't have to. You're welcome to use film. What you would have to do is have the film processed at a photo store, or if you know how to do it, you could do it yourself or buy the equipment, and there's a recording that goes over how to process film, um, because we would have been working in the lab. But you would have to have the film processed and then scanned, and then work on the images digitally. So actually, it's easier to just shoot digitally at this time. And there's a possibility that schools might open up more over the course of this semester, and that we would be able to meet in person, which would be great. But no guarantees on that, and at the moment anyway, that isn't looking that likely, so we can hope for the best, right? And hopefully you guys are all safe and practicing safe distancing and so on. But anyway, back to this camera. So this camera is what's called a small format camera, and it uses 35 millimeter film. And I'm sure you've all seen this type of film. Some of you may actually have used it. I know it's ancient technology for many of us. It's called 35 millimeter film because the width of the film here is 35 millimeters. The actual size of the frame that is formed when we take pictures is not 35 millimeters. It's actually 24 by 36 millimeters. And that is determined by this little window in the back of the camera called the shutter. And we'll talk about that in much greater detail in a little bit. For those of you who have never used a film camera, this is what the inside looks like. And they're designed the digital SLR cameras, DSLR cameras, are by and large, in terms of basic design, the same as the film cameras, except they don't use film. And they have a whole lot of electronics inside as well. So the basic idea of the camera is to focus the light entering the camera through the lens. This is the lens. And then record that information either onto film or digitally. So film uses silver technology, and there are certain silver compounds known as silver halides that respond upon exposure to light. So we load this film into the camera and then expose it to light. And when we do that, the silver that's embedded on the film responds to that light. You can't see the response. The change is at the molecular level, but something called a latent image is formed. And we then process the film in different chemicals to develop the film, that image, to make it visible, and then to fix it, to make it permanent and impervious to further change upon exposure to light. The information is stored on the film, and we then use the film to make prints from these images. So with black and white film, a negative image is formed, and so there's a reversal of what you see. So light areas appear dark, and dark areas appear light or clear. When we make a print from it, we make a positive print from this. Actually, we make a negative print from the negative, and two negatives make a positive. So we get a reversal onto photo paper. And so the light areas again appear light, and the dark areas again appear dark. So I just want to go over briefly how to load film into the camera if you haven't done that. This is a fully manual camera. There are also film cameras that are electronic, and so they function a little bit differently in how one loads film and how one unloads film. But I'll go over this camera first. In order to load the film, you have to open the back, and on digital cameras you can't open the back. There's a digital sensor here in place of film. But with film cameras, you open the back, and on this type of camera you pull up this knob, and there's a little latch, so you trigger it and then you open the back. On electronic film cameras, you may have a little latch on the side instead of this thing here. On the inside, as hopefully you can see, there's a little well here. That's where the film cassette goes. The film is then pulled across this area. This is called the film plane, and it goes in front of this shutter. That's a window that opens and closes. And then in order to load the film, you have to tuck the end into this take-up spool. So this is the film, and it goes in like so, generally, and then you push this down and make sure it's locked in place. You then pull the film across this area, being very careful because you never want to touch the shutter. It's under pressure, and it's very delicate. And this is called the tongue or the leader. You can see it's been kind of cut out. And that allows us to tuck it into the take-up spool on the other end. If you have an electronic or automatic camera, you'll probably have a little red dot right here. And that tells you how far to pull the leader. You leave it there and then close the back, and the camera will automatically forward the film to number 1. With manual cameras, that doesn't happen. You have to do it by hand. And so, let me adjust this so you can see it a little better. So you have to tuck this leader into one of the little slits on the take-up spool. And then you forward using this forwarding lever. And you may need to push the button, which is called the shutter release button, in order to turn it and forward the film. And you want to be able to see that it is turning. The film has these little holes called sprockets, and the sprockets go over the nubs on this spool here, and that's what will turn the film. So I'll just do it one more time. Make sure it's turning, and it is. And then I close the back, and there should be a counter here, and I want to forward the film to number 1. I can tell it's forwarding because this spool should be turning as I forward the film. If it isn't, you might want to check to make sure that the film is loading correctly. So I've loaded to number 1, and then of course I go out and take pictures and, you know, find lots of different things. I'll talk about the specific settings that you'll want to be using and how to determine those. But assuming that you're doing that, or you have a fully automatic camera that's doing it for you, which I don't want you to do, you've shot a whole roll. Rolls of film come in 2 different sizes, I guess. One that will give you 24 frames, or one that will give you 36 frames. Doesn't matter which you decide to use. You don't save money if you buy the 36 roll over the 24 in terms of what you pay per frame. It's about the same. So it's up to you. But you've shot the roll and you've gotten to the end. And what happens is, as you shoot, the film is pulled out of that cassette and onto the take-up spool. So at the end of the roll, all of the film is on the take-up spool and out of the cassette. Now, film is sensitive to light. It's very sensitive to light. So you never want to deal with it out in light. So you don't want to pull the film out and take a look at it, because that will ruin it. And you never want to open the camera when the film is loaded, except at the very beginning of a roll or at the end after you have rewound the film back into the cassette. So as I said, after you finish shooting the whole roll, all of the film is on this take-up spool. And so you don't want to open the back. Let's say you do open it by accident. You don't want to stand there saying, oh shit, uh-oh, now what do I do? You want to say, oh shit, and close it really fast, with the hopes that you haven't exposed everything. Okay. That said, you need to rewind the film. And auto cameras, many of the auto cameras will do it as soon as they sense, or it senses that you've gotten to the end of the roll. Some of them have 2 buttons that you have to push simultaneously to rewind the film. And that is a safety measure, so you don't, if you hit one button accidentally, it won't rewind. You have to purposely hit both. With a manual camera, you have to, for most of them, you have to push this button that's at the bottom of the camera. And what this does is it releases the tension in the take-up spool. So if you try and rewind the film Without doing this, it won't want to, and you'll tear the film. So you push this button in, like so. That was pushed in. And then at the top here, there's this little lever. Sorry, you can't see my hand there. This lever that pulls out. And you then rewind the film. You may have to wind a couple of turns before you feel the tension. And then you should feel a sudden release of tension as the film leader comes off that take-up spool. And then you want to keep rewinding so the film is completely back into the cassette. I didn't rewind it completely because I may want to use this roll of film. But you want to rewind it completely into the roll, and then you will bring the roll into the darkroom and under normal circumstances, or take it into a lab that will process your film. Okay, and Green's camera should be able to process the film for you, and Bay Photo as well. Okay, so if you're shooting film, that's great, because of course this is supposed to be a film class, but it's up to you. Okay, any questions? Anybody? No?
No?
Yes. No? Yes? Yeah, dear? No, okay. So I want to talk very briefly about how the camera functions. And so if you see this, if you can see this diagram here, it's looking at the camera from the side, and, or I guess like that. And so you see the camera body and the lens, and then some of the mechanisms inside. So light enters the camera through the lens, and the light is focused by the lens, as the light entering our eyes is focused by the lens in our eyes. And then the light enters the camera. And it is intercepted by this thing here, which is called a reflex mirror. And let me just take the lens off this, and then maybe I can catch the reflection here so you can see that there is a mirror in here, and that's called the reflex mirror. And the reflex mirror is what allows us to see what will be recorded by the camera before we actually release the shutter and take the picture. So there's an offsetting in terms of height between where the eyepiece is at the back, and you can see that here on the diagram, and the level of the lens here. And it's there's about an inch or so in difference. And so if you were just to look through this eyepiece, if it had a window at the front, you actually would be looking out higher than the level of the lens. So the reflex mirror bounces the light up into this upper area, where there is a thing called a pentaprism, penta being 5. So it's a prism, a 5-sided prism, and the light is bounced around in the pentaprism and then out through the eyepiece here. And so this allows you to see what will be recorded. Once you've set the camera, we'll of course go over all the settings, and hopefully you've looked at some of the readings and my class notes. But once you've done all the settings and composed your image, you take the picture, and you do that by pushing this button, which is called the shutter release button. And when you do that, several things happen essentially at the same time. The first thing is that this mirror, the reflex mirror, pops up out of the way. And this allows light to pass through into the body of the camera. It then encounters the shutter, which is this window here, back here. So let me just, hello, dog.
My bad. My bad.
No worries. Always nice to have pets. So when I release the shutter, this mirror pops up out of the way, and the shutter opens. So that's open. And when this happens, light is allowed to pass all the way back into the body of the camera to this area here, which is the film or the sensor plane. And so the film or the digital sensor is exposed to light. And as I said, with film, a latent image is formed, a change occurs at the molecular level. With digital cameras, a sensor records the information. And we'll talk about sensors again in a little bit. But at any rate, the information is recorded, the shutter closes, the reflex mirror goes back into place, ready to make another image. So that is how an SLR functions. There are cameras that do not have reflex mirrors. The first small format, that is 35 millimeter cameras, did not have reflex mirrors. They are called, sorry, I'm just setting this down. They're called rangefinder cameras, and they look very similar to, let me get there, sorry. They look, now why isn't that here? I apologize. They look very similar to SLRs, but again, they lack the reflex mirror. And there are some problems associated with that, which in modern times, those have been taken care of. The point and shoot cameras, phone cameras do not have shutters. They turn on and off electronically. So they function a little differently. They're also quieter, because what you're hearing here, if you can hear it, is the sound. It's not the shutter opening and closing, that's very quiet. It's the reflex mirror popping up out of the way. But at any rate, shutter or no shutter, reflex mirror or no reflex mirror, light is allowed into the camera. It exposes the film or the digital sensor, and that information is stored either on the film or digitally. And then again, with film, we need to process the film in order to make that image visible and then to make it permanent. The information is stored on the film, and we use the film to make images. With digital photography, the sensor is made up of an array of tiny little sensors called pixels, and each pixel records information, color information, and information about how much light there is. And sensors are made up of millions and millions of little pixels. And that information is put together and organized. The information is then digitized, and that means that the information from each pixel is given a numerical value based on color and the amount of light. That information is then organized into a file or a file type, JPEGs, TIFFs, RAW files, and then transferred to a memory card. And there are two main types of memory cards, compact flash cards and SD cards. The information is transferred to the memory card. So unlike film, which both records and stores the information, with digital photography, the sensor records the information, but the information is then transferred to and stored on the memory card. Okay, so the basic functions of the camera. Again, hopefully you have looked at the modules and looked at some of the basic information here. So the welcome module, of course. And then the second module says the basics, the camera, camera terms, and so on. notes on, these are my notes, the notes that we would be going over, that I would be writing out as I talk. But these are these are the notes anyway for you to look at, probably after you've done the readings. So notes on cameras, different sizes and types, and then something we'll go over briefly: ISO, ASA, and the light meter, the lenses, different types of lenses, how we allow light into the camera, the aperture and the shutter, and then on from there. So the camera has two main parts, I guess. The camera body and the lens, and the lens. With SLR cameras, you can take the lens off and use different lenses interchangeably. Depending on the manufacturer of your camera, you have to generally buy lenses that correspond with the manufacturer, or there are aftermarket lens companies that make different mounts. The configuration here of the mount, different mounts for different camera brands, and I know, heard of the main, the most commonly seen brands: Nikon, Canon, Pentax. Those are the main ones for film cameras, certainly. But Nikon and Canon definitely for digital. Also for digital, some of the electronics companies, Sony and Panasonic, make excellent cameras. Any questions? Anybody? No? Okay. So I hope that you have done... Yes, question.
I have a question. It's not really related to this. It's more, do you know when our first assignments will be due?
A good question. Hopefully at the end of next week, possibly at the beginning of the following, depending on how everyone is doing with getting their Adobe situation in order. I hope that you got I hope you got an email from Adobe, but I also just sent an email last night with a copy of what they supposedly sent you. So you need to get Adobe, your access to Adobe, and all of your names and emails have been sent to Adobe, so there shouldn't be any problem with access. You just have to sign in through Canvas, and the instructions are there. So the first assignment is just to go out and shoot. I want you to shoot what would be the equivalent of a roll of film, so about 30 images. And I then and this will be posted, I want you to go through them and select probably 5 or 10 images that you think are the best, and then we'll take a look at them and talk about them, okay? The second assignment will be a more technical assignment, but we need you to have gone over, and me to have gone over, the technical aspects of the camera and how they control certain effects that we want to see in the images. Okay, but longer answer to your question. Probably in about 10 days to a little bit more than that. Your first assignment will be due. And again, it's nothing, I don't think it's too arduous. You just have to go out and shoot some images, okay?
Thank you.
Mm-hmm. Okay, so the lens. The lens focuses the light entering the camera. And in many ways, the lens is more important than the body of the camera. The body of the camera has to do what it should do. It should function accurately. But the lens determines how sharp the image is, how sharp the images are. a cheaper or not very good lens can distort the light entering the camera, can bend the light in ways that it shouldn't be bent. You can have distortions, things looking weird in the image, or colors may not be transmitted accurately, and so on. So you want to have a good lens. That doesn't mean that you need to spend thousands of dollars on a lens, because actually manufacturers, I think, miraculously make some excellent lenses that are really, really cheap. So anyway, you do want a good lens. Lenses are described by what's called their focal length. So let me just get here. So when someone asks you or me what lens you or I have, we tell them what the focal length of the lens is, and that's printed generally on the outside of the barrel of the lens, or around the outer element here, often on the barrel of the lens as well. Excuse me. But the focal length of the lens is not the physical length of the lens. It's a distance between 2 points, one of which is located in the lens and the other of which is located in the body of the camera. So the point in the lens is called the nodal point, and it's the optical center of the lens. And that means it's the point at which the light is focused as it enters the lens. The light is then transmitted back into the camera, where it is eventually intercepted by the sensor film plane. And so the focal length of the lens is the distance between these 2 points. Okay. And that distance is always described in metrics, in millimeters, and not in the imperial or English system in inches. That's just how it is. Lenses come in different focal lengths, and they are divided into 3 main categories depending on the length of the lens. And the first category is called normal, and that is because these lenses give an angle of view that approximates that of the normal human eye. So our field of vision has a central portion, and we see, assuming our eyes function relatively normally, everything in that area we see with essentially equal weight. As we go out, as the angle of view increases, it becomes more and more peripheral. We, unless we actually look there, we see things, but not as much. So normal lenses have an angle of view that fall into this area here. Shorter lenses are called wide-angle lenses. So here's this. So these are normal lenses described in millimeters, and the shortest of them are about 35 millimeters, not to be confused with 35 millimeter film. So the film has a width of 35 millimeters. The 35 millimeter lens has a focal length of 35 millimeters. The shorter the lens, the wider the angle of view. And so wide-angle lenses are shorter than normal lenses and have even wider angles of view. And the very short lenses can give almost 180 degrees of view, which is a straight line. As the focal length decreases, as it gets shorter and shorter, you get something called barrel distortion, and that's a bending of the light. So if you've ever seen images, let's say a room filled with people, and at the edges of the frame, the people look kind of stretched out like Gumbies. That image was made with a short lens, with a wide-angle lens, and you're seeing barrel distortion. Okay. The opposite of the wide-angle lens is called the telephoto lens. It's a long lens, and that's crooked, isn't it? Telephoto lenses have an angle of view that's narrower than that of the normal human eye. And the longer the lens, the narrower the angle of view. So these lenses are used to isolate areas in your field of vision. So wildlife, sports photography, where you may not be able to be there or may not be advisable to be there on site right there. You can use a long lens to get there. And so a 1000 millimeter lens, for example, has a 2.5 degree angle of view, which is teeny, and certainly teeny as opposed to 180 degrees. These are very long lenses, many of them, and they require their own tripods or they just kind of fall over. So if you've seen sports photography where you see a ball of sweat dripping off Rafael Nadal's nose, the photographer is not standing right under Rafa, photographing him. The photographer is way back with all the other press, using a really long lens to record that. Wildlife photography, if you see one of those beautiful images of a Bengal tiger taken in the Sundarbans in India, and you see the details of the hair on its nose, and obviously the photographer was not right there in the tiger's face. It would have been probably the last photograph he or she ever made, so a nice legacy, I guess. But the photographer was back at a safe distance using a really long lens to get that kind of image. Okay, so we use different lenses for different types of photography, and as you go on in photography and decide what types of images you like to make, you'll probably start using, be more specific in the type of lens you use. You don't have to, but that's how we tend to do it. Many of us use something called a zoom lens. And so a zoom lens is a subcategory of lenses. And zoom lenses incorporate many focal lengths into one lens. So zoom lenses. On my digital camera here, I have a zoom lens. Zoom lenses come in different configurations of focal lengths, from wider angle to more telephoto. So there are many, many, many different configurations. I've just listed here a few of the more commonly seen ones. This one is an 18 to 140 millimeter lens. And so it goes from wide angle, 18 millimeters, out to moderately telephoto, 140 millimeters. Some lenses just go from wider angle to slightly longer within the normal range, or from wide angle to normal, from wide angle to just barely telephoto, mildly telephoto, from wide angle to very telephoto, depends on the lens. Zoom lenses are very convenient. So instead of buying 2 or 4 or 10 or 50 different fixed focal length lenses, like this one, which is a 50 millimeter lens, a normal lens, you can buy 1 or 2 zoom lenses and have many, many, many focal lengths available to you. So they're very convenient. So of course there are drawbacks. They're not quite as sharp as their fixed focal length counterparts. And the maximum aperture, which we'll talk about in a moment, is not as large. And so that's called the speed of the lens. And these lenses are not quite as fast as their fixed focal length counterparts, but they're also very convenient. So many, many photographers use zoom lenses. So those are lenses. Any questions? Anybody? No, okay. The body of the camera. So there are 2 mechanisms that we use to allow light into the camera. And let me get to those. And they're called the shutter and the aperture. And we kind of looked at the shutter in that I showed you where the shutter was. So the shutter controls the length of time that light is allowed into the camera. And so this is the shutter again, back here. and it opens and closes, and you can control the length of time that the shutter remains open. And so there are different shutter settings called shutter speeds, and I've given you these shutter speeds here, and I'd like you to learn them. I've given you what are called the whole stop numbers. Some cameras have, many cameras have intermediate settings. Some of them are in 1/2, what are called stops, 1/2 stop settings. Other cameras have 1/3 stop settings. But they all have these shutter speeds. So these are the ones I want you to learn. They start at 1 second and then go down into fractions of seconds. Some cameras have preset shutter speeds that are longer than 1 second as well. This film camera does not. This digital camera does. It goes out to 30 seconds. However, all of these cameras have a B setting, which stands for bulb, and in that setting, you can lock the shutter open for as long as you want. So in the bulb setting, so it just stays open until I let it go. And so this is how long exposures are made. Most people get something called a cable release that attaches and allows you to release the shutter and lock it open so you don't have to stand there with your finger on the button. But night photography uses long exposures. Motion, when you want to show something moving as a blur, you would use the bulb setting. Anyway, the shutter speeds can be seen on this this little knob here, or if you have an electronic camera, you should be able to see them on the LCD, on the liquid crystal display right there. So the shutter on 35mm cameras is located in the body of the camera. With some other types of cameras, and I've described those in the notes, there are larger format cameras. In many of those, the shutter is built into the lens, but for our purposes, the shutter is located in the body of the camera. So the shutter is one of two mechanisms that we use to allow light into the camera. The second is called the aperture, and it is located in the lens. And so it is an adjustable diaphragm that opens and closes. I don't know if you can see that happening here. There. Closed, open. So obviously the more open it is, the wider the aperture, the more light enters. And as you close it down or stop it down, less light enters the lens. And so we use these two mechanisms to control the overall amount of light entering the camera. So let me just go to shutters for a second. Apertures, sorry. Uh-oh, that's all messed up. Okay, so sorry about that. The aperture, I will fix that, is the adjustable diaphragm located in the lens that controls the intensity or the amount of light entering the camera. And the aperture settings are described as f-stops. And the f is always written as a lowercase f, not sure why, followed by a number. And that refers to the diameter of the aperture at that particular point. The diameter being the distance across a circle where that line passes through the center. So obviously the larger the aperture, the more light enters. The smaller the aperture, the less light enters. These are the f-stop numbers, many of them. I've started here at f2 and gone to f22. Some lenses go further on either end. The rule is the smaller the f-stop number, for example f2, the larger the size of the aperture, the diameter. The larger the f-stop number, the smaller the diameter or the size of the aperture. As with the shutter speeds, these are the whole stop numbers, and your lenses will probably have half stops or perhaps third stop increments as well, but all lenses have these numbers. Some of them don't open up all the way to f2. So for example, most zoom lenses have a maximum aperture of f3.5. Some of your lenses will stop down beyond f22 to even smaller apertures. But within that, these lenses have these f-stop numbers. Notice that the numbers, every other number doubles, so 2, 4, 8, 16, the next would be 32, and then 64. Those lenses are not found on 35 millimeter cameras. F 2.8, 5.6, 11 would actually be 11.2, but they rounded it. 22, and the next would be 44. There's a relationship between and among both the shutter speeds and the apertures that you need to know. And that's what happens to the amount of light when you change the shutter speed and or the aperture. So with the shutter speeds, the shutter speeds are described in seconds and in fractions of seconds. And as you change the shutter speed, you change the amount of light entering the camera. So as the shutter speed gets shorter, that means the length of time the shutter remains open decreases, and the amount of light entering the camera therefore decreases. So if I change my shutter speed from 1 second to half a second is half of 1. So the shutter remains open for half as long, and half as much light enters the camera. And that is true wherever you start. You can start at 1 second or a 15th of a second or 1/250th of a second, wherever. That relationship holds true. So in this example, I've changed from a 30th of a second to a 60th of a second. So I cut the amount of light in half. When I change from a 60th of a second to 1/125th of a second, I again cut the amount of light in half. So I've cut it in half and cut it in half again. So half of a half is 1/4. So 1/125th of a second lets in 1/4 as much light as a 30th of a second. And we can get that answer by multiplying these fractions. Don't worry, it's not a math class. But half times a half is 1/4. So when you multiply fractions, if the numerators, the upper numbers, are the same, all you have to do is multiply the denominators, the bottom numbers. So 2 times 2 is 4. And so 1/2 times 1/2 is 1/4. If I then change to if I then change from 1/125th of a second to 1/250th of a second, I again cut the amount of light in half. And from 1/250th to 1/500th, I again cut the amount of light in half. So a half times a half times a half is 1/8. So 1/250th of a second lets in 1/8 as much light as a 30th. 1/500th of a second lets in 1/16th as much light as a 30th of a second. So half times a half is a 4th, times a half is an 8th, times a half is 1/16th. And I can keep going. So 1/32nd, 1/64th, 1/128th. If my shutter speed goes out to 1/8000th of a second, as it does on this camera, then I would keep going. In the opposite direction, well, let me go here. Here's another way of describing what's happened to the amount of light entering the camera. If this entire circle represents the amount of light entering the camera at our starting point, which in our example is a 30th of a second, when we stop down to, here we go, 1/60th of a second, we cut the amount of light in half, and we're left with 1/2. When we change, if we then change from a 60th of a second to from a 30th of a second to a 60th of a second, we cut that half in half, and we're left with 1/4. If we then change the shutter speed from a 60th of a second to 1/125th of a second, we cut the quarter in half and we're left with 1/8. We change from 1/125th of a second to 1/250th of a second, we cut the 1/8 in half and are left with 1/16. And if we then change again, we're left with 1/32 and 1/64 and 1/128, and so on. So we cut the amount of light in half each time we stop down. When we open up, we double the amount of light entering the camera. So when we go from a faster to a slower shutter speed, the shutter remains open for a longer period of time and more light, therefore, will enter the camera. So if 1/4000th of a second is half as long as 1/2000th of a second, then 1/2000th of a second is twice as long as 1/4000th of a second, and it therefore allows in twice as much light. So again, it doesn't matter where you start, here at a 4,000th of a second, here at an 1/8 of a second. When you change the shutter speed from a faster to a slower shutter speed, you double the amount of light entering the camera per stop. So if we change from a 2/50th of a second to 1/125th of a second, we double the amount of light because we're going from a faster to a slower shutter speed. When we change from 1/125th of a second to a 60th of a second, we again double the amount of light. And so we've doubled it and doubled again. So 2 times 2 is 4. Therefore, 1/60th of a second allows in 4 times as much light as 1/250th of a second. If we then open up again to from a 60th of a second to a 30th of a second, we've now opened up by 1, 2, 3 stops. We don't count the first one. So we've doubled the light, doubled it again, and doubled it again. So 2 times 2 is 4, times 2 is 8. So 1/30th of a second lets in 8 times as much light as 1/250th of a second. If we then open up again to 1/15th of a second, we've doubled the amount of light entering the camera again. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 1/15th of a second lets in 16 times as much light as 1/250th of a second, and so on. So 16 times, then 32 times, and 64 times, and 128 times, and 256 times, and so on. That relationship holds true with the apertures as well. So it's not as obvious, but the relationships are comparable. So when you change the aperture from a larger to a smaller aperture, you cut the amount of light in half per stop. And when you open up, when you change the aperture from a smaller to a larger aperture, you double the amount of light entering the camera per stop. So these two things are put together, they're used together. And that is the next subject for technical stuff. But in terms of using your camera, you will need to use these two mechanisms together. And so cameras contain something called a light meter. And the light meter looks at the world, and it takes into account the amount of light that's available, and also something called the film speed, which I'll talk about in a moment. And based on these two pieces of information, it will tell you, or your camera, how much light you should let in. So it doesn't say, I divine that you should set your shutter speed to 1/250th of a second and your aperture to f16. It uses as a starting point wherever your camera happens to be set at that moment. The light meter is activated by lightly depressing the shutter release button, and you should then see a display in your viewfinder. And if you have an electronic camera, you should see a display on the LCD, the liquid crystal display. If you have a screen back here, you should also see it there when you activate the light meter. Cameras have different modes in terms of how much control you have over the camera and how much control the camera has. And so these modes range from fully automatic, where the camera does everything, to fully manual, where you do everything. With basic film cameras, you do everything. So they are manual. You have to set the aperture, you have to set the shutter speed, you focus. You know, many auto cameras or electronic cameras also have autofocus. These cameras do not. You also have to set something called the ISO, or the ASA, or the film speed. So let me just go to that for a moment. So the ISO, or the ASA, or the film speed, indicates how sensitive the sensor of the film is to light. And so with film, that refers to how much silver is contained in the film. And the more silver there is, the more sensitive the film is to light. The less silver there is, the less sensitive it is to light. And these sensitivities or settings were given numerical values. And these are called ISO, which stands for International Standards Organization, or ASA, American Standards Association. These are organizations that quantify information. It's also called the film speed because it refers somewhat indirectly to the fastest shutter speed that you can use. So as you can see, these numbers double as they go down, I guess, and they're cut in half as you go back up. The lower the number, the slower the film speed, and the less sensitive the film is to light, so the less silver it contains. What that means is that more light is required to make an exposure, a proper exposure, meaning one that's neither too light nor too dark. As the sensitivity increases, as the silver content increases and these numbers go up, the sensitivity of the film to light increases. The sensitivity, or the amount of silver that the film contains, affects how much light is required. So if you have a low ISO rated film, or a slower film speed, which is less sensitive to light, you need more light to make an exposure. So let's say you're outside on a bright sunny day where you have lots of light. That's great. You can use a less sensitive film. But if you're in a darkened situation, like in a club or bar where the light is subdued, or at twilight, where there isn't that much light, then you would want to use a film or an ISO rating that is more sensitive, that contains more silver. So you might say it makes the most of the light that's there. You can find out what the ISO rating is, or the film speed, with film, just by looking at the film, the cassette, or the box it comes in. So this is black and white film. It's made by a brand called Kentmere, which is a kind of lower end film, but that's okay. And in big numbers it says 400, and so that means that the ISO rating, or the ASA rating, or the film speed, is 400, and you can see that right here, kind of in the middle, a little lower, but in the middle. Films come in different film speeds. There aren't as many films made anymore, but we still can get them. The film speeds we tend to see are 100 or 125, 400, and then 3200. And 3200 is the fastest film speed that's made. I've included these numbers because digital cameras have ratings that go beyond that, so they're much more sensitive to light, and you can use them in lower light situations than you could with 3200 speed film. So, what happens when you change the ISO rating? When you change it, the light requirement changes. So, in a general sense, you need more light with less sensitive ratings and less light with more sensitive ratings. But the relationship between the sensitivity and the light requirement is very specific, and it's inversely proportional. So I can start at any place I want, or any rating, but here I've started at 100, and I changed the rating to 200. So I have gone from a less sensitive to a more sensitive rating, and it's doubled. So 100 is half of 200, or 200 is twice 100, and that refers specifically to the sensitivity. So I have doubled the sensitivity of my film to light, and I now require less light. So specifically, I require half as much light. So if the sensitivity doubles, the light requirement is cut in half. And that holds true per setting, per ISO rating. Again, it doesn't matter where you start. So if I change my ISO from 400 to 800, I've doubled the sensitivity, and I therefore require half as much light. And the relationship in some ways is similar or comparable to the relationships between the apertures and shutter speeds in terms of what are called stops. In the opposite direction, if I go from a more sensitive to a less sensitive rating, so in this example from 6400 to 3200, 3200 is half of 6400, and it is therefore half as sensitive to light as 6400. And it therefore requires twice as much light as 6400 because it's half as sensitive. And that relationship also holds true, and it doesn't matter where you start. So as I said, the light meter, which is built into your camera, takes into account the amount of light that's available. It has built into it something called a solenoid, which can read how much light there is. And it then takes into account the ISO rating, because different ISO ratings require different amounts of light. Based on those two pieces of information, it tells your camera how much light is required and whether or not you're allowing in the proper amount of light. So here we have the light meter is built into the camera. It reads the amount of light entering the camera through the lens, and that's called TTL, or through the lens metering. And using the ISO rating, tells your camera whether or not you are allowing in the correct amount of light. There are different types of light meters. Almost all of the electronic cameras have all of these, but the default is to matrix, which is the most complex metering system. Your film camera, if you have a film camera, it depends on the camera that you have. Most of them are beyond center weighted. They kind of evaluate what's going on, but at least they give more weight to what's in the center of the frame to expose correctly for that, as opposed to something all the way on the edge. The light meter display may be very simple. It may be more complex. You may just have a little dot that illuminates green when you're correct, a minus sign if you are underexposing, plus sign if you're overexposing. The display may be more detailed in how many stops you're under or overexposing by, or in either numbers or hatch marks. You may have a needle that goes up and down. That's more common in this type of camera, a film manual camera. And the needle goes up and down as you increase or decrease the amount of light entering the camera, and usually want it to level out in the middle or line up with the shutter speed or so on. Okay. So what I'd like you to do is to go out with either your film or your digital camera and fool around with these things. I want you to look at the shutter speeds and apertures and the ISO ratings. So with digital cameras, you change the ISO rating here with this ISO button, and then use one of these rings to change the ISO rating. If you have a film camera, you have to set the ISO rating manually. And there, in this camera, there's a little window here, and you have to lift up this center thing, and so you can rotate the ring to set the appropriate ISO number. And if you have a film camera that is manual, it's very important that you set it correctly, because if you don't, the camera will think that you have a film in there and a certain sensitivity that if incorrect, will have the light meter give you an incorrect light meter reading. Some newer film cameras read a barcode on the film, and this is called DX, the letter D and the letter X, DX coding, and it's a barcode. And electronic cameras have little sensors built into the alcove where the film goes that will read that barcode. So if you have that kind of camera, you don't have to worry about setting the ISO rating. But if you have a manual film camera, you do need to worry about setting the ISO rating, and you want to set it correctly. So again, I want you to fiddle around. If you have a digital camera, go ahead and change the ISO ratings and see what happens to your light meter readings as you do so. Okay. Cameras, again, they come in different modes in terms of how much power or control you have over the camera. And if you have a camera that has auto settings, I don't want you to use them. I want you to put the camera into manual, and you have to set the aperture, the shutter speed, and the ISO rating. Okay. So that's a whole lot of stuff crammed into what's probably seemed like a long time for you, but a relatively short lecture. Any questions? Any questions? Anybody? No? No? Okay, well, I will post this recording, but I hope that we will have more Zoom meetings. I realize that this time may not work for everybody, but hopefully it works for many of you, and at any rate, you can watch the recording. Even if you're here, you can watch it again. It will be posted on Canvas in the modules, and there will be a module for Zoom recordings. Okay, so when this is processed and so on, I will load it onto Canvas. Anyway, for those of you who turned your cameras on, it was nice to see you. Thank you, Ben. And
I have a question.
Yes, Joanna.
Are classes going to be every week on Wednesday at this time?
No, this is my generally this is my office hour time, and our class is what's called asynchronous, so we don't actually have a meeting time. In fact, you never have to see me. You can do the entire class without ever coming to an office hour or a meeting. But I will be having some Zoom meetings, especially to look at your work. Of course, I will make written comments about your work that will be posted with the grades, but and you will need to look at other people's work in the discussion section, which we'll go over on Canvas. But I hope that you guys can attend the Zoom meetings because I think it's certainly easier to convey things when we're face to face and looking at things, and also more, I don't know, genial. It's more like a class if we can meet in person. But if this time doesn't work for the majority of you, I will, I'll send an email and ask if there's another time that works better. But no one, it's not going to be 100%. So hopefully you guys can make them. But are you asking because this is a bad time, Joanna?
Oh, well, no, I was just asking so I could change if I had to change my availability at work so I would have time for the class in the morning. Yeah.
Gotcha. Okay. So hopefully it will be on Wednesdays at 1:30.
Hmm.
And I'll send out an email asking about that and to that effect and so on. Okay.
Okay, thank you.
Any other questions, comments, issues? No. Okay. Well, delightful to see some of you. I'm glad you guys came. Hopefully you'll come again. Again, go use your cameras, fiddle around. If you have questions, email me or come to my next office hour in a week, or if it's more urgent than that, email me and we'll try and do something sooner. Okay. Other than that, I hope that you all are safe and healthy and have an enjoyable rest of the week and weekend. Okay. Take care. Bye.
Bye.
Bye.